getting us underway today are the guys from Cheesecake Energy. Guys, what I'd like to do now is introduce you to the audience. Mike, good morning to you. How are you doing?
Doing very well. Thanks, Andrew. Hope you're doing well too.
Excellent. Good. It's a tough gig, of course, always going first, but you're very welcome, and we wish you every good luck. So, over to you, Mike.
Superb. Thank you very much. Good morning, everyone. My name is Mike Simpson from Cheesecake Energy Limited. Ladies and gentlemen, there has never been a better time to be in energy storage. Bloomberg's now projecting $662 billion being invested in storage by 2040. The paradigm has shifted. With renewables already cheaper than fossil-fired electricity, the problem isn't generation anymore. It's about timing. California is already looking for a gigawatt of new long-duration energy storage, by which they mean 8 to 12 hours, by 2026. For us at Cheesecake Energy, that's our specialty. Lithium-ion is a fantastic technology. It's grown at a phenomenal rate, and it really does perform. But it comes at a cost. As well as the price tag, it takes 500,000 gallons of water to create a ton of lithium. Lithium-ion is also one of the world's biggest consumers of cobalt, which is sourced from countries like the DRC. When it comes to heavy lifting, moving bulk renewable power, it's not the answer. We need something that's affordable, that's long-lasting, and that is clean. Ladies and gentlemen, allow me to introduce the Cheesecake Energy Limited supertanker, the world's greenest battery. We've developed thermal and compressed air energy storage at 30 to 40% lower capital cost than lithium-ion. When there's surplus electricity from the grid, we take ex-service truck engines that we've repurposed as electric compressors to compress air. As that air is compressed, it gets hot. We store the heat in tanks of gravel at very high temperature, at 600 degrees C, and very low cost. We store the air in pressure vessels from the compressed natural gas industry. What we're doing is bringing together proven industrial hardware into a long-lasting 25-year system that can deliver 500 kilowatts to 30 megawatts for 4 to 12 hours. We can deliver benefits all the way along the electricity value chain, from generation to distribution to consumption. Let's start with the consumption side. Bus operators are desperate to go electric, but they're facing major costs and disruption to upgrade their grid connection to get enough power to charge their bus fleet. That's where we come in. With our supertanker system, we can double the charging capacity at a given site without the hassle of upgrading the grid. That means lower energy costs, it means going electric sooner, and it means new income streams for that site. We're playing into some huge global markets here that are growing at incredible rates. Storage alongside renewables is forecast to be a $50 billion market by 2025. Distribution and consumption, equally sizable markets. We're setting up as a hardware supplier, delivering hardware and warranties into energy storage project developers. The cheapest lithium-ion systems at the moment installed, we're looking at around $400 per kilowatt hour. Our system should be $300 and last for much longer without the degradation. We're very well set up to be playing into project developers like Zenobē, either sitting alongside or replacing their lithium-ion solutions. And we're also engaging with distribution network operators like UKPN. We have a suite of patent applications, 7 filed, including 1 at national filing stage. And we also have a powerful body of specialist technical know-how. But really, we understand that the key in this sector is speed to scale, which is where having the existing supply chains really helps us. We also have strategic partnerships in place to allow us to get there sooner. There are some amazing technologies kind of vying to take this space, from lithium-ion, flow batteries, liquid air. There's a lot of interesting stuff happening, but none of them offer the full package. We can deliver an affordable, modular, scalable system that lasts for a long time and that has incredibly low environmental impact. To date, we've built a large-scale test rig. This is a thermal store test rig at 2 megawatt-hour scale, complete with heat exchangers and air circuitry. We've had a Shell Game Changer award to develop the technology, And our prototype is being fully funded by Highways England, who are looking to understand energy storage at motorway service stations. We've got an MOU with Volvo Trucks for the truck engines, and we're in discussions with Nottinghamshire County Council about deploying our prototype at their bus depot. We've also had further interest from major international bus operators, and we're engaging with global players in the renewables, particularly the mining sector, and also in transport. We have a fantastic team. Our CTO, Seamus, is a professor of mechanical engineering at the University of Nottingham, and he's a world-leading expert in mechanical energy storage. And Paul Codd, our commercial director, is a former energy consultant who cut his teeth delivering energy solutions to the mining sector. For my part, I'm an engineer too. I trained at Cambridge, MIT, and Imperial, and formerly worked for Rolls-Royce and Shell. Got a fantastic advisory board, including Steve and Eric, who are both former Shell execs, and Antoine, who is a Green Angel investor with Green Angel Syndicate. All this is made possible by our superb technical and commercial team. In terms of next steps, we're looking to complete our prototype in Q4 of this year, so that's fully funded. We'll be then deploying that with an end user early next year, before moving to one of a series of pilot installations by the end of 2021. We'll be then going into commercial deployment by 2022. We've already received 1.4 million in grants to build our prototypes, and we're looking at first commercial revenues in 2021, before profit in 2023, moving on to revenues of more than 40 million by 2025. We're here to raise £1.5 million of investment to go alongside our existing non-dilutive funding. That investment would allow us to pilot the system in key sectors, build out our network of strategic partners, and productionize for scale up. We've got a highly differentiated technology, responding to clear market needs on a global scale, very high growth potential, and with a supply chain that's already in place for existing industrial kit with no barriers to scaling up further. It's a cheap, scalable, and green technology. And with your support, we can build this to the point where we achieve a trade sale to a major power player like Shell or Aggreko in 2025-26 for more than 60 million. With that, we'll be turbocharging the energy transition and allowing this technology to reach its full potential. Thank you very much.
Mike, thank you very much indeed for getting us off to such a great start this morning. John has been monitoring the question and answer box whilst you've been presenting. Of course, we'll continue to do so throughout the day. So, John, perhaps you would like to put one or two of the questions that have come through to Mike. John, over to you.
Thanks, Andrew. Hi, Mike. A couple of two-part question in from Pippa Gawley. Are your truck engines using diesel? And the second part is, how does your carbon life cycle analysis compare with lithium-ion?
Understood. Glad you asked that question. It's a good one. No, so there's no diesel used in our system anymore. So those truck engines are end of life. They are remanufactured before they come into our system, and then we run them with electric motors. So the electric motor goes on the front, and we're driving them as a compressor, and then we also run it kind of in reverse as an expander. The motor becomes a generator to generate again. So no emissions, completely zero emission system, no nasty diesel, we're on displaced diesel. On the second part, in terms of the life cycle, I don't have kind of precise figures, but the nice thing is that the energy intensity of the materials we're using rock, we're using air, we're using steel. It's a tiny fraction of the energy intensity of the materials that go into lithium ion. So it's a tiny fraction. Yeah, that's probably the clearest I can give you.
Okay, thank you, Mike. Second question: are there any limitations in your supply chain? You're using some reconditioned engines. Any limitation?
Yeah, another great question. So this is something that we've been kind of looking at for a while, and actually the news is very positive. So we're using this in existing kind of diesel engines. There's a huge supply of those. We're starting with Euro 3 diesel engines, which aren't really used on the roads in Europe anymore. There's a huge supply of those. But actually, we're going to see that stock continually replenished as we move to phase out of internal combustion engines. We can draw on an existing supply chain for manufacture and also for maintenance for automotive engines that is otherwise going to see a bit of a tail off in terms of the demand. So actually that's quite a powerful play for us. And we've looked across the rest of the system, and it's a similar story. It's kind of very large scale production capacity.
So the questions are now flooding in, but we've just got time for one quick one from Bernie Balkin. What's the round trip efficiency of the system? Could you give a quick answer to that?
Yeah, good one. So we're looking at around 65 to 70% for our production systems. So that's a little bit lower than lithium-ion, but it's more than competitive. It's particularly at lower capital cost and much longer lifetime. It's very much taking on that performance.
Excellent. Thanks a lot, Mike, and back to you, Andrew.